In GATE 2008 there is a 4 marks question, linked answer question from CADCAM. GATE 2008 question. If you look at the question number 5 and 6 in GATE Academy material, GATE 2008 question, 4 marks question they have given asked. So the question looks big, but it's very simple. You can easily score 4 marks in just less than a minute, if you know the concept of basic length unit which we have discussed. So I will read the question. So it's a linked answer question, and question number 5 and 6 of 2008. Question number 5 and 6. So in the feed drive of a point to point open loop CNC drive, the stepper motor rotating at 200 steps per revolution. So speed of stepper motor, first speed of stepper motor is equal to 200 steps or pulses per revolution. Similarly, the revolution drives a table through a gearbox and the lead screw nut mechanism. Pitch of the lead screw is 4 mm. The gear ratio is pitch of the lead screw, which is equal to the 4 mm, means the distance travelled by the table for one rotation of the lead screw. The gear ratio formula also he has given. Gear ratio equal to output speed, rotational speed, by input rotational speed. Output rotational speed by input rotational speed. To understand it clearly, we will draw a simple diagram of this, as we have discussed in BLU concept, where so this is stepper or servo motor. So motor where we give power to run the shaft. So this is gearbox, where gear ratio you can increase or decrease this to increase or decrease the speed of the lead screw. This is lead screw. Here it is table or even tool. This is the mechanism. So power will transmit from stepper motor to gearbox, and gearbox to table will move. Table will move to and fro, and power will transmit from stepper motor to gearbox. So here gear ratio equal to 1 by 4 equal to speed of the lead screw by speed of motor. I will just give notation, speed of motor Nm. So this is a gear ratio, speed of lead screw by speed of stepper motor. And next we can get here from speed of the lead screw stepper motor. So what he is asking is, stepper motor executes one step per pulse of a pulse generator. Okay, there is another thing which is connected to stepper motor. This is pulse generator. So pulse generator executes, the stepper motor executes one step per pulse of pulse generator. So for each pulse it will rotate, it will be, one step it will move, and for each one rotation of the shaft, the according to the gearbox, the lead screw will rotate. So this is a mechanism, and they have given diagram also for this. He is asking, fifth question is, basic length unit of the table moving corresponding one pulse of the pulse generator is the table movement corresponding to one pulse of the one pulse generator. Okay, so question is basic length unit. Calculate the BLU, basic length unit, which is the table movement corresponding to one pulse of the generator. So one pulse of generator is equal to one step of the stepper motor. Table movement corresponding to one pulse of generator. So here one pulse of pulse generator equal to one step of stepper motor. So for one step equal to 1 by 200th of revolution of the stepper motor. For one pulse step, the stepper rotates 1 by 200 revolution of stepper motor. How we get is, for 200 pulse steps, the stepper motor rotates 1 revolution. 200 steps equal to 1 revolution of stepper motor. So one step equal to 1 by 200th of revolution of the stepper. For 1 by 200th of revolution of stepper motor, what is the rotation of the lead screw? So for example, if you look at the gear ratio, for one rotation of the rotation of stepper motor equal to 1 by 4th rotation of lead screw. Okay, so for one rotation of stepper motor, the lead screw rotates only 1 by 4th. Similarly, 1 by 200 revolution rotation, or 200th of revolution 1 by 200th of rotation, complete rotation, 100 200th of revolution or complete rotation. Complete rotation of stepper motor equal to 1 by 200 into 1 by 4 fourth of rotation of lead screw. So for one pulse, it explains, for one pulse the stepper motor rotates 1 by 200th of the complete rotation, and which rotate, I mean next lead screw will rotate less than that, that means 1 by 800th of the one rotation. So for one pulse, so as our definition, pitch of lead screw equal to 4 mm, which is 1 equal to 1 revolution of lead screw. So for 1 revolution of lead screw, the distance travelled by the table is 4 mm. For 1 by 800th of rotation of lead screw, the distance travelled by the table is equal to 1 by 800 into 5, sorry 4 is a pitch, it is equal to 1 by 200, it's equal to what, 200 mm. So it is, if you write in microns, it is how many microns? 5 microns. Simple. So for the question, fifth question, which they asked what is a BLU, basic length unit, we have calculated, which means for one step of the stepper motor what is the distance travelled by the table, so that is BLU. So options are, all are like 0.5 microns, B 5 microns, say 50 microns, D 500 microns. So all are near. Option C is correct answer. Similarly, sixth question. So a consumer insists on the modification to change the BLU, the CNC drive, to 10 microns. So to change BLU from 5 microns to 10 microns without changing the table speed, the modification can be accomplished by which of the following satisfies? To change the value from 5 microns, which of the following option is correct? So option A is changing u to 1 by half and reducing f to f by 2. Next, change u to u by 8 and f to 2f. See, change u to u by 2 and f is constant. D, change f to 2f and keep u as constant. So these are the options. So which one satisfies to increase the BLU from 5 to 10 microns? So we have to check. And so u, actually here u equal to gear ratio. So if gear ratio is present, gear ratio is u1 equal to 1 by 4, which is initial. u2, if we decrease to 1 by, or gear ratio decrease to 1 by 2, so that means increasing the gear ratio, then what will happen? The frequency, the effect of f, there is no effect. There is no impact of frequency f on BLU. So if gear ratio is 1 by 2, then BLU equal to 1 by 200 into 1 by 2. Earlier it was 1 by 4, so now it is 1 by, sorry, instead of 800 it is 400 into 4. It's equal to 1 by 100. It's equal to 10 microns. So option A is correct answer. For 6, A is correct answer. A is correct answer. Okay. Next, question number 13. Get 2001 2 marks question. Two marks question. So here the given data is, in NC machining operation, the tool has to move from point, tool moves from point A 5,4 to B 7,2 along a circular path with center C 5,2. Before starting the operation, the tool is at A, that is 5 comma 4. The correct G and M code for this operation is, options are A N01, G03, B N01, G02, C N01, G01, D N01, G0. So this is enough to solve the problem, but anyway, if you want, I will write complete options, like from 7 comma 2 to I5 J2, X7 Y2 I5 J2, X7 Y2 I5 J2, X7 Y2 I5 J2. So these are the options. To solve this problem, you need to draw the diagram. So first of all, you have to mark the points of A and B in the chart. So for example, it is 5 comma 4, 5 7, and it is 2 4. So first point, you need to 5 comma 4, x-axis 5, y-axis 4. This is the point. Next point is 7 comma 2. This is another point. So it is moving, center is at 5 comma 2. This is C, this is A and B. So A is 5 comma 4, B is 7 comma 2, C is 5 comma 2. With the C as center, the tool is moving from A to B. So this is the notation. The tool is moving from A to B. So for this, what is the correct G code? So that is a question. So if you look at the movement of the tool is moving clockwise rotation. So look at the options which satisfies for that. First option is N01. For in every option N01 is there. N01 means it is the first operation. And if you look at the 7 comma 2 and I5 comma 2, is the center is 5 comma 2 and 7 comma 2 is the end point. It is giving end point. From that center it is moving to end point. So G03. So G03 means anti-clockwise rotation. G02 is clockwise circular rotation. G01 is linear motion. G00 is rapid traverse. So out of this, if you know only G02 enough to solve this question. So B is the answer. Answer is B. This is the answer for this question. So if you know first of all, you need to draw the diagram on XY plane, and then you have to understand how the tool movement is taking place, whether it is clockwise or anti-clockwise from the center, and then look at the codes, whichever is satisfies, just that is the answer. Very simple. Next is one assignment question is there. Assignment 9th question. Assignment question number 9. The question is match the following M code and definition. M code and definition of each code. So if you know M code, you can solve this problem easily. So first one is A M03, B M04, C M05, D M06. Spindle rotation clockwise. Second option, spindle stop. Third option, tool change. Fourth option, spindle rotation clockwise. These are the options. If you look at this, so first of all, M03. What is M03? M03 is spindle rotation clockwise. We know that. So A four. Next is M04, spindle rotation anti-clockwise. Next M05, spindle stop. So remaining is tool change. So answer for this question is C, which is called A4, B1, C2, D3. So if you know the M codes, you can solve this question. So this is the end of the CAD/CAM CIM chapter. So by the end of this chapter, there are few points which you need to remember. Then you can solve any question. So those points are, I will just write it down. Important note points. First one, G02, spindle rotation clockwise. If you know this, you can solve 1/4 of the old gate question, just only 1 point. Next, point to point motion and continuous motions. Next is BLU, basic length unit, which is also important. That's it. If you remember these 3 points, we can solve almost all gate questions, but you need to draw the diagram for calculating whether it is clockwise rotation or anti-clockwise rotation. This is very simple chapter. Spend only if you spend 2 hours by listening this class, and that's enough to solve any question in any gate exam. Thank you.